Okay, 1.3 midpoint and distance. The midpoint and distance formulas are rather important to us. They are used quite a bit throughout. A midpoint of a segment is a point that it divides a segment into congruent segments. What does congruent mean?
Like on the same line.
Nope.
No. I don't know.
Josh?
It's like same angle, or I think.
Well, congruent could be a same angle.
Yeah, like same angle.
Right. Dylan, what'd you say?
Equal.
Equal. Now, objects are congruent, measurements are equal. I'm only putting equal there so you can keep that in your brain, okay? Equivalent, congruent, equal. So, the midpoint of the segment PQ, point P being x1, y1, point Q being x2, y2, is capital M stands for, guess what? Midpoint is x2 plus x1 divided by 2, y2 plus y1 divided by 2. Do you notice these big parentheses here?
Yeah.
This is a midpoint. Got it? When I add two things together and divide by 2, what am I finding? When you add two things together and divide by 2. Nope. In any not geometry, any math. I add 6 numbers together and I divide by 6. I add 10 numbers together, I divide by 10. What am I finding? Not the median. Mean, average. Okay? Okay. When you add things together and divide by the number they are, you're finding the average, yes? So what we essentially did is find the average. Of the x's and y's, didn't we? Okay. This is something you're going to need to remember. You're going to need it on a test. So you probably at some point when you get a chance, if you don't have one right now, I would tonight when you're doing your homework, highlight this formula so you have it and you can see it. You hear me? I'm not waiting for everybody to do it, so you guys can do it later. So, when we do this, we're going to add the two together. If one of them is negative, you're not going to add. You're going to do what? Subtract, just like other algebra, and divide by 2. So it says find the midpoint of each segment with the given points. So C is negative 2, 5. D is 8, negative 12. So the midpoint equals, parenthesis, x2 plus x1. So 8, well, it's not plus, it's going to be minus. Why is it minus? Because it's a negative. Divided by 2, comma, because remember this is an x and this is a y. And then negative 12 plus 5 divided by 2. Combining the x's, combining the y's, dividing by what number? 2. Why are we dividing by 2?
Because that's the numbers.
There's 2 numbers. Is that what you're going to say? Okay, so I have 4 over 2. How about 6 over 2? I divided earlier and I divided again. 6 over 2. And what, negative 7 over 2? So 6 over 2, we can't leave it that way. It is what? 3. So 3 comma negative 7 over 2. Rule of thumb, guys, if I don't give you a decimal, don't give me a decimal. Got it?
Got it.
And don't ever give me a mixed number unless you're telling me a measurement of a room. Okay, so the next one, just because they're decimals, am I going to do this problem any differently?
No.
No. I'm modeling working down. Which direction should you guys be working?
Down.
Down. Okay, so midpoint is x plus x divided by 2, y plus y, and the y's are going to actually subtract. Why are they subtracting? Because the numbers are
Negative.
negative, and they actually we're going to add them when we're done because they're both negative. And it really doesn't matter which x or which y you put first, as long as these two are 1 point and these two are 1 point. Does that make sense what I'm saying? Okay, so let's see. 12, you guys subtract, I subtract. We better get the same thing, right? Okay, I got negative 3.7 over 2 and negative 10.8 over 2. Did you guys get that? Okay. Can I leave a decimal in a fraction? No. That's like putting a fraction in a fraction, right? And we're dividing by 2. So should dividing by 2 be pretty easy?
Yes.
Okay. So we know it's going to be a negative here. So negative 2 goes into 3 how many times? Once. Carry a 1. 2 goes into 17 how many times? 8. And then we'd have a 0 with a 1, right? 2 goes into 10? 5. When I divide by 2, it's going to end in a 0 or a 5, correct? Eventually.
Yeah.
So the next one's pretty easy because it's just negative 5.4. There was nothing to carry around, was there?
No.
Okay, again, why did I give me a decimal? Because I was given what to start? Decimal. If you don't give me decimals, you leave it as fractions. Questions?
No.
That pretty basic?
Yeah.
Okay, so these are midpoint. I wanted the middle point. So if I had this graph down here, I'd find the point that would give me like right in the middle, right? But what if I want a point like 7/8 of the way? Or a point 4/5 of the way? So we got to get 4/5 of the change of the x's, and not 4/5, that's down here. 7/10 of the change of the x's, and 7/10 of the change of the y's. How do you find change?
Subtract.
You subtract. That's how you find change every time, isn't it? You take
What
the
they
big,
give you,
you take the ending number minus the beginning number, and you have the change. Correct? That's how you've been doing it forever. So that's what we're going to do. So we're going to do the x's first. So I'm going to take the change of the x's and multiply them by 7/10. So the furthest one to the left is
X.
13.
Well, yeah, 13.
So 13 minus
11. Or 3.
3, the x's,
Yeah. And then
times 7/10.
Yeah.
And then we're going to set up the y's too. We'll do the work in a second.
So then it'd be 11 minus 4.
So it'd be 11 minus a negative 4. So it'd be what?
Add 11 to the side, so
Plus 7/10.
4. Yeah.
So we need to remember, find the differences, right? And the reason why I put that in there is the differences, because when we subtracted the negative, it became a positive, right? And we just got to remember differences. So, what's 13 minus 3?
10.
10. So 10 times 7 over 10. Now, I am going to push. you guys to reduce before you multiply. Because if I multiply first, then divide, I have huge numbers I have to divide, correct? Reducing is division. But if I reduce first, my numbers are smaller, correct? I can reduce up and down or diagonally. And this is 10 over 1. Might be the only time I do that for you. If you need it, you do it. I just see it in my head. So, 10 goes into 10, yes? So they all go to 1s. So I just get 7.
Yeah.
Okay. So now I got to come over here. So 11 plus 4 is 15 times 7/10. And 10 doesn't go into 15, but something goes into 15 and 10. 5. So this becomes a 3 and this becomes a
Or 2.
2.
Yeah.
So I get 21 halves. Okay. So now, actually I should have written it over here again. What we have here is how much we're moving. So this is a positive 7, yes? Could it be a negative 7?
No.
Yeah. It could be a negative 7. It could go the other way. If I would have gone from here to here, it would have been a negative. It would have come down here. Okay? But this one says from A to B. So it says this direction, doesn't it? Do you see that? Does everyone see that? Okay. So that means I have to take my initial point, 7 plus 3, and 21 fourths, or 21 halves minus 4. So what is 7 plus 3? 10? That was easy, right? Now, how do we subtract fractions? We have to get common denominators. So 4 becomes what over what?
2 over.
No, it becomes 8 over.
8 over
Oh, wait.
2, right?
Yeah.
So 4 becomes 8 over 2. So what is 21 minus 8? What? 13. So I get 13 over 2.
Yeah.
So 13 over 2. So in your brain, you should know 13 over 2 is 6.5, correct? Okay, so this says that if I go over 10, so 10 would be right here, and I go up 6.5, which would be right here, that point is 7/10 the way to point B. Is it?
Yes.
Yeah, 7/10 is greater than half, right? Is that bigger than half? Yep. Now, can anybody guess what part you'll forget to do?
Subtract. Those. Or, no, fine.
It's the very last that people forget to do. They find the difference, they multiply by the ratio, but they forget to take it from the point they start. Okay?
Yeah.
Now I want 4/5 from B to A. Okay? From B to A. So now we're not going to do it, we're not going to take our difference from up here we did A, right? Now we're going to use what? B?
B to A. Yeah.
So we're coming this way.
4. Yeah.
All right, different. So this one we went this way.
That's a
Now we're going to do this way.
same but opposite. Yeah.
Same but opposite. So how are we going to do that?
It's a good question. Ms. Meg.
Don't know.
Subtract.
Do the exact same steps, but then at the end, instead of taking the A, like 3.
It'll be a
Okay,
negative though.
so we're B to A, yes? So we took B minus A because B was the second one, right?
Yeah.
Now we're gonna take
B.
minus,
Third.
we're gonna do A minus B because A is my ending,
We're trying to find it.
right? So I have X's,
So would it be 3 minus 13
so 3 minus 13
times 7 over, or 4 over 5?
times 4 over 5.
And then negative 4 minus 11? Is that how
So
you did that?
Y's, yep.
Negative 4 minus
So negative 4
times
minus 11 because when we find the difference between two numbers, we take the second one minus the first one, right?
Mhm.
Okay. So we get negative 10 times 4/5.
Hang on.
Yeah.
So 5 goes into 10 twice, so I get negative 8.
Sure. Yes.
So now I get, what, negative 15? And 5 goes into 15,
3 times.
3. So I get negative 12. So now it makes sense to get negative because we're going backwards, aren't we? We're going backwards on the number line.
Yeah, we said
So
that.
we have plus 13 and plus 11.
No.
Yes?
Yes.
So negative 8, positive 13 is 5.
Sure, I'm not good at negatives.
Well, 13 minus 8 is 5, yes?
Yes.
Okay.
Oh.
You can move it around, can't you?
Yeah, but
'Kay.
still, I'm not.
12 minus 11 is
Negative 1.
negative 1. So let's see if this makes sense. So 5 would be like, well, there's 6, right?
Yeah.
So 5 would be like right here.
Yeah, like on the.
And then
line.
would this be like negative 1?
Yeah.
Yeah, because this is negative 4.
Yeah.
So right here would be 5, negative 1. Now, think about it. Is this about 4/5 the way from here to here? Yeah. Does that make sense?
Mhm.
Okay.
That's not too bad. It's just
No.
a lot of steps.
It is a lot of steps, not too bad. We're not done with notes, but I want you to see your worksheet because I want to make sure you guys have something straight before you do it. So I'm going to hand this to you. We're going to do a little, like one little thing on here. We're going to label something, and then we're going to go back to our notes, okay? So don't keep working on your homework. And I'm putting it on the side I want you to look at, so don't turn it over. Now, you are not going to be able to work on this piece of paper. You have to work on another piece of paper. You're not going to have enough room. Okay,
You need to work on this.
so I want you to look at this right here. Do you see that there's a third of the way, 2/3, 2/3, 1/3? C to D, D to C, C to D, D to C. That's important. We discussed it, yes?
Yes.
We probably should know the points on this graph. It's kind of faded, so I want to make sure you have your points correct. So what is the coordinates of C? Look close on your paper, not up here.
1, 7.
Negative 1, 7. You guys good with that?
How did you get that?
Well, because it's negative 1, 7.
Okay.
I can see it, Kale. Power of the glasses, right? Okay,
You 4 eyes.
what about D?
5.
5, 1.
I see that one.
Okay, now that you have that, you should be good, correct?
Mm-hmm.
Okay, I want to make sure everybody was using the correct points. Back to notes.
I definitely want to put like 6 on it.
I know, that's why I wanted all of us to have the same. Okay.
That's all we have to do on that worksheet?
No, you have to do the whole thing.
No,
That's
I mean
all.
like that's literally the whole reason we gave it to us.
Yeah, because I wanted to make sure you all had the same points. Because if you don't have the same points, you're not going to have the same answers.
Yeah, I know.
Okay, the distance D, that's how we label distance, between 2 points P and Q is, now we're going to write a formula.
That M equals thing.
Well, this is distance.
Oh, D. Oh.
Okay, so we write it as D of PQ. That means D from the distance from point P to point Q. That's how we write this. So we have the square root, big square root,
Oh.
of x2 minus x1, the quantity squared. Fourth hour was sure you guys did a little bit this last year, and I think you did. But it also should be familiar with, kind of remind you of slope too, except for the square, not without the squares, right?
Mm-hmm.
Plus y2 minus y1. Said one, wrote two. 1 quantity squared. Think that's important?
Yeah, probably.
Yes, big time. Hopefully the yellow. So make sure you have it so you can find it. You need to label your pages so when you're working on your test and you need the distance formula and you don't quite remember it, you want to be able to go, oh, look, 1, 3 distance formula midpoint. Go to that page.
I'm surprised.
Okay? So, we're going to have application problems for this one. Fun. Okay, a pitcher throws a ball to the batter. Who? Look at that.
Pitcher.
What's it missing? Who? What's it missing? The H. Hits the ball to the shortstop. If the ball travels in a straight line between each, what is the total distance traveled by the ball?
Round your answer to the nearest 10.
So, we need to go from the pitcher to the what?
The pitcher to the batter.
The pitcher to the batter.
So that little line thing.
And then we need to go where?
From the batter to the...
The batter to the shortstop.
Yeah. Does it have to be that perfect?
No, for me it does, but it does not. Okay, so this is point P, B, and S. Pitcher, batter, shortstop, right? What is our plan? What are we going to do with that? Find the what? Well, find the points first. Okay, so pitchers at where? 5, y'all agree?
Yes.
Okay, where's the batter? 0, 0.
Mm-hmm. I can't see you.
And where's the shortstop?
5-10.
I agree. 5, 10. So how are we going to solve this? Find the total distance traveled by the ball.
Do the same thing we've been doing.
So we're going to find the what? Distance. And what are we going to do with those two distances? Add them together. So we're going to take D of P comma B. What's P comma B stand for?
Distance from point P to point B.
Right, pitcher to batter.
Yes.
Plus the distance from the what? Batter to shortstop. So we're going to have to use this formula not once, but what? Twice. Now, it says 1 unit equals 9 feet. So when we get an answer, we got to multiply it by what? 9. Okay. So I have the distance from the pitcher to the batter. Oh, I love zeros. Subtracting zeros is amazing, yes?
Sure.
You're not going to have all zeros, just to let you know. Okay, big square root. Now the difference of the x's. So we want to do 5 minus 0 or 0 minus 5.
5 minus 0.
Okay? So parenthesis 5 minus 0, quantity what? Squared? You subtract first, then square.
Yeah.
Plus, well, if we did 5 and 0, we have to do 5 minus 0 again. It honestly does not matter which point you name point 1 and point 2. Did everyone hear me?
No.
As long as these two are in one point and these two are in another point. It really doesn't matter which one's which because you're squaring it. So you're always going to have a positive answer, correct?
Mm-hmm.
Okay, so we still have the square root. Well, 5 minus 0 is 5. Squared is 25. So I have 25 plus 25. Now I would normally keep going down, but I don't have room to do both my things. So I now have the square root of 50. But I can't leave it the square root of 50 because we have perfect squares in there, and right? So what is the perfect square in 50? Perfect square is a number that's made up with two identical numbers, yes? How do I get 50? Like what multiplied together gives you 50?
10 and 5.
10 and 5. Think perfect squares, guys.
That's what I'm trying to. I don't know. That's what I'm trying to. There's no.
Tony, you know?
25 and 2.
25 and 2, yep. Is 25 a perfect square?
Yes.
Yep. So I actually have the square root of 25 and the square root of 2. What is the square root of 25? What?
5.
5. So I have 5 and the square root of 2. That's not a perfect square, is it? So we just leave 2. So we now have the length or the distance from pitcher to batter, yes?
Yeah.
Okay. Oh, we said we were going to multiply this by 9, didn't we?
Yeah.
Okay. So then I need the distance from the batter to the shortstop. So you guys tell me what to write. Got the square root. Got my first parentheses. I'm going to move it up. You guys have the equation on your paper.
Yeah.
What goes here?
10.
10 minus, nope,
It's 5.
X
It's
is,
5 minus 10.
nope, it's 5
5
minus 0.
Zero.
Yeah. Yeah.
Squared plus
10 minus 0.
10 minus 0. Could I have 0 minus 5 and 0 minus 10? Yeah,
Yeah.
doesn't matter. Okay, so 5 minus 0 is 0. Squared is 5 squared is what?
2.
25
Or 20.
plus what'd you say, Cal?
100.
100. So I have the square root of 125, yes? Okay. So when I say what is the perfect square in the number, I'm talking about what multiplies together and has what of them is a perfect square. So 125 has a perfect square in it. 25 and 5. So I have the square root of 25 times the square root of 5. So what's the square root of 25? 5. And does the square root of 5 have anything? Nope. So it's just the square root of 5. So I have 9 times 5 square root of 2. Because I'm just filling in my plan, right? Plus 5 times the square root of 5. Now, if my radicans, anybody know what that word means?
No.
So it's what is under the square root is called a radican. My radican, excuse me. If they're the same, I could add these two. Like terms. Are they the same?
No.
I square root of 2, square root of 5. Can't do it. If you have a calculator, if you do not have a calculator and have an iPhone, you can get a graphing calculator that you can use at home It's calculate 84. You want to write it on there or look it up or whatever. If you have an Android, anybody have an Android in here? Yes? Wabbit, EMU. I said rabbit with a W. EMU. It's a free graphing calculator you can use also. The nice thing about it is that it will do everything. We can put it in exactly like this. So I can put 9 parenthesis 5, and right here there's x squared. See the square root right above it? See right there? It's blue. So I hit second square root 2, and I'm still in the square root, so I move it over. I'm kind of blurry, aren't I?
Yeah.
There you go. Plus 5, and I want the squared again, and 5. And it's keeping reminding me to get the parentheses, so I get out of the square root and put the other parenthesis,
Whoa.
and I hit enter.
I don't think I got that.
Okay, so how far approximately did that ball travel?
264.
Point,
26.
well, it says nearest tenth.
Oh.
So 3 feet. Tenth is 1 decimal. Okay. Do you guys want to take a minute and get that application on there on your phone? How much time do we got? Or do you want me just to do it and we do it if we have time?
I don't know, what else do we have left?
We got one example left. We'll have time.
Okay.
Okay.
Let's do this.
So go to your app store. It's called Calculate 84. The other one you guys can get is Desmos. And it's really nice too. It's easy. Desmos is free also.
Did you change your app icon?
'Cause ours is blue.
And it looks like this.
No, that's fine. That looks the same thing.
Yeah, well, it's blue.
I didn't
Maybe
change
it's
it.
different
Yeah.
because of the pen.
Yeah. So you can use Desmos or Calculate 84.
What's
Did
real
I tell you do those already?
photo math?
Yep, I got PhotoMath. Because CalcChat is a worked out solutions for my pre-calc book. And they paired up with PhotoMath now, so you have to PhotoMath it.
Photo math costs money.
So, no, it doesn't. Not when it's with that book. Did you find yours, Josh? Wabbit EMU. Did you find it?
It didn't directly show, but I'm seeing like multiple graphing calculators.
Let me see them. There are multiple ones out there, but there are not multiple good ones. Does that make sense?
Oh,
And they may not be updating it
This is
anymore.
not that hard. Are you trying it?
Yeah.
I think I just have a calculator in my house.
If you guys have a 2-line calculator, that is great. If you don't, it's going to be harder to do. You can just use Desmos. It's just as good. Okay, Desmos is great. Actually, it's better than what this is because you don't have to solve anything for y. You can just throw it in there the way it is. Okay, let's do the last one while that's downloading on your phone.
Do we get to use those for like tests?
If you get to use it on a test, I give you this, not your
Do
phone.
those work though?
Why wouldn't they work?
Not for our stuff. Those
Mhm.
are fun.
Look. So I do 9 parenthesis 5 square root of 2 plus 5 square root of 5. Oops. Parenthesis.
Yay.
See? It worked.
Wow.
If you're getting a calculator, guys, if you want to buy one, this is a 2-line calculator so you can see what you put in and the answer. That is much better than just a basic one that you can't see it because you have to do things kind of backwards on those. Okay. So, next one. How far does the shortstop need to throw the ball to get it to reach the first baseman?
I don't know.
So now I have to go from the shortstop to the first baseman, right? So what's the coordinates of the first base?
10.
0.
10-0?
Yeah.
But then
Okay.
5.
You guys want to try this one on your own?
Yes.
Okay, you try it. I'll give you a second, and then I'll start.
Actually, no.
Why not?
know what I'm doing.
Yeah, I don't either.
Okay, so I'm gonna go from the shortstop to the first base, yes?
Do my shoulder.
Okay,
Oh.
so I have the square root. Pick a point. You wanna do shortstop to first base or first base to shortstop?
Short stop.
Okay, so it'd be x minus x
X minus 6 and y minus 1.
squared
Yes.
plus y minus y squared. See how I just said x minus x, y minus y? So I have 5 minus 10 is
-5.
negative 5 squared is 25 plus 100. So it is the square root of 125, which we already said was 5 square root of 5. But now we need to multiply it by what? 9, because that's my unit conversion, right?
Yes.
So if I do 9 times 5 square root of 5, well, that's just 45 square root of 5, isn't it? Feet. That would be an exact answer on a test. That is what you would give me. Okay? Because on this test, you won't have a calculator. So then on your assignment, it wants it to the nearest tenth. So 45 square root of 5 is about 100.6 feet.
What is that?
Are we done now?
Yep.
Can I use the restroom?
Leave your phone there. So your assignment is the worksheet from